All right, we are going to be graphing exponential functions. So basically what we've got here is we've got like, y is equal to c times a raised to the x power, and we're going to be doing all the ideas of the graphs of what that is going to look like. So the idea is match the formula. For this one, it says match the formula for with its graph right here. So you're going to take this y is equal to 1.3 raised to the x power. You're going to go into Desmos. So this is definitely a Desmos opportunity. In fact, most of this video is going to be Desmos. And then you're going to graph it. So when you graph it right here, you'll notice right here, you have to kind of look at what the options are. And you'll notice right here the scale is from -5 to 5 in all 4 cases. All right, so when you graph your Desmos, you are going to have to kind of massage your axes here, your x-axis and your y-axis, to kind of match what my math lab is offering you right here. And so when you do that, and you'll see, okay, so it's kind of gently sloping up. You'll see it crosses at 1 right here. And so we need to figure out which one of these graphs gently slopes up and crosses at 1. And you can see, oh, it's definitely D. So you can see that the answer in this case is D. And how did we do that? Well, we let Desmos do all the work, and that's it. So here I want to call to your attention this thing down here. So what are they saying? What does that mean? So they're saying we want the graph to go from -10 to 10 on the x-axis. That's what this thing x is. And then from -10 to 10 on the y-axis. And this scale, SCL scale, means the intervals are going by ones. I know it says 2, 4, 6, 8, 10, but you can also see it's going by ones, right? So the little hash marks are going by ones. So that's what that is. And so when you graph, you need to make sure your Desmos is kind of the same scale from -10 to 10, -10 to 10, kind of going by intervals or intervals of 1, a scale of 1. All right. So now, but the question is, how do you figure out the value of C and A? And that's what they're asking us. So the idea is, let's zoom in. Okay, we're zooming in here. So when we think of that equation, y is equal to c times a to the x power. Okay, so let's first think about when x is 0. So when x is 0, we want to figure out what is y. All right, so now we see that y, actually, when x is 0, we know, right here, when x is 0, we know that y is equal to 4. So we're going to put in 4 for y. We're going to leave c alone. Now a raised to the 0th power, because I replaced x with 0. So because we can see when x is 0, y is 4. So what is a to the 0th power? Well, a to the 0th power is 1. Right here. This is 1. So that means c has to be 4. Because this says c times 1 is equal to 4. Well, that means c is equal to 4. So we now know that c is equal to 4. All right. Now we have to figure out what the heck is a. So now we're going to go back and kind of redo ourselves a little bit. And now this time we're going to use x being 1. Now I'm specifically choosing x being 0 as this first part. That's what we did right here. Now we're going to do x is equal to 1. I'm looking at that because I see that when x is 0, y is 4, right there. And then I can see right here, when x is 1, y is 8. All right, I can just see that. And that's why I'm specifically choosing x being 0 and then x being 1. Now when x is 1, I see that y is equal to 8. So we're going to start with that original equation, and I'm going to replace y with 8. Now we know that c is 4. We don't know what a is, but we know that x is 1. Why? Because I said so right here. When x is 1, y is 8. And so, let's see. Well, a to the first power is a. And so this is saying 4 times something is equal to 8. Well, what does that mean a is? Well, that means a has to be 2. A has to be 2. So we now know what our C is. It's 4. We now know what A is. It's 2. And so our equation is y is equal to 4 times 2 raised to the x power. That is our equation. And that is what we're going to put into our MyMathLab right here. So you're going to leave C alone, and then in your box, you're just going to put 4 dot, as in times, 2 raised to the x power. That's what you're going to put in MyMathLab. Now to verify, I put it in Desmos, and look at my graph right here. And of course, I'm trying to match the graph on MyMathLab. So I went from -10 to 10, -10 to 10, and I get this really steep slope up, right? And that's exactly what I see right here, a really sharp, steep slope up. In fact, if I want to go back, I can see that, oh, when x is 0, y is 4. And when x is 1, I can see y is 8. So my graph matches the graph that they gave us, which means 4 being C and 2 being A is correct. All right, so we're going to do the same thing. We need to find the value of C and find the value of A. And we know that we're going to start with y is equal to CAX, CA raised to the x power. And we're going to start with 0, 8. And so that tells us that y is 8. And this is going to be C times A raised to the 0th power. And we know that a raised to the 0th power is equal to 1. Anything raised to the 0th power is always equal 1. Always, 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 always. And if you want to know why, you're going to have to ask me in class. And so that tells us that C has to equal 8. So now we know that C is equal to 8. And so in our equation, we got y is equal to, and then we have C right here, and then we have times, and then we have A raised to the x power, right? But we now know that C is 8. So that means I can take that C, get rid of it, and I can replace it with an 8. All right, so there we go so far. And that's this part. So now that we know that C has to equal 8, our equation is y is equal to 8 times A raised to the x power. And I'm going to go back over here, and I'm going to see that when x is 1, y is 2. So when x is 1, y is 2. So our equation becomes 2 equals 8 times A raised to the first power. And so A raised to the first power is equal to A. So this is 8A is equal to 2. So dividing both sides by 8, we now see that A is equal to 1/4. So that means, going back to our equation here, that means this A can be replaced by 1/4. And this is what you're going to type in. Well, actually, not the whole thing. Whoa, yikes. It's this portion right here. So this is the part you're going to type into the box. Oh, so actually you're not, because this is actually saying what is C? Well, C is 8. So this you're going to put in 8. And then eventually it's going to ask you, okay, well, now that you know that C is equal to 8, what is A? And A is equal to 1/4. So this is cool. So graph f of x. So here it is, right here, and state whether the graph depicts exponential growth or decay. So first thing we're going to do to graph it is we are going to use our magical, wonderful Desmos. And so when I scroll over here and I'm going to type in this, all right, and you might have to get a little creative in how you create or type this into Desmos. But once you've typed it, the other thing you have to do is you have to look and you have to notice that all of our options, the scale is going from -5 to 5 in all 4 cases. So when you graph this into Desmos, I kind of failed to do that. I really should have expanded and stretched this out so that we're only looking at from -5 to 5. This little portion right here is what we should be looking at. And so I can see that it starts and then it swoops up pretty steeply, right? So when I go over here and look, my 4 choices, the only choice that makes sense is A. So again, we are going to graph this function right here, and we're going to graph it using Desmos, again, our favorite software. And the other thing is I want you to notice the scales again are all from, in this case, -10 to 10. So when I graph my Desmos over here, I have to make sure that my scales are similar, going from -10 to 10 in both cases. And you'll notice on this case, I needed to be creative and I needed to put the 1/9 in parentheses in order to make it work. The x kept getting attached to something other than what I wanted it to be attached to, so I had to put parentheses. So a big old heads up on that you might have to put in parentheses. And so when I look, I can see that I've got this swooping thing going down right here like this, kind of like the letter L. So looking at my options, if I'm looking for the letter L, well, I do have an L here and an L here, but when I look at my Desmos, I see that it never dips below the x-axis. It doesn't go down. It stays above that x-axis, and really it looks like it turns into the x-axis. It just becomes microscopically close. If I were to zoom in, this line would separate from the x-axis. So what is my answer? Well, the answer is going to be C. So on this one again, it says for us to graph, and then it's got this stuff. So what the heck does all that mean? Well, again, you're going to use Desmos, and when we look at this notation, what they're saying is, they're saying the x-axis needs to go from -4 to +4, and it's going to go by ones. And then the y-axis is going to go from 0 to 8, and its intervals are going to go by ones. So when I graph this into Desmos, again, I had to get creative, by the way, and yeah, there we go. I had to get creative, and I needed to put the 5 inside parentheses in order to make this work. And then when I did that, I also had to make sure that and I used the little wrench in order to create the scale, but I wanted it to go from -4 to 4 on the x-axis and from 0 to 8 on the y-axis. And this is the result, the way it ends up looking. So I get the right kind of like magnification, the right perspective. And so that immediately tells me of my 4 choices, it says that the answer is C. So now you typing this into Desmos. I'm going to go over and type in Desmos. Now we know that the graph of 2x, so y is equal to 2x, we know what that's going to look like. 2x is going to look something like this. All right. So 2x minus 2 is really just going to take the existing graph and lower it by 2. It's going to end up looking like that. And so that tells us the answer is going to be C, because it took the regular base graph of 2x and lowers it by 2. Now just to prove it, I typed it into Desmos, and there we go. So you'll notice it's the typical graph, but lowered by 2. And so that makes it, I'm going to go back here, in this case, it makes the option C. So this one was particularly tricky for me typing it into Desmos. For whatever reason, Desmos is struggling with this exponent. So you'll see that what I had to do to make it work is I had to put parentheses around the x plus 1 to keep it up in the exponent. Every time I was typing in the plus 1, it would drop it out of the exponent, and it was kind of a pain in the rear. So the parentheses ended up being my friend. And when I graphed that, keeping the scale, because I had to look, and I noticed that all of these options, the ranges and the domains and the ranges were going from -10 to 10 in both cases. And so I wanted to make sure my graph in Desmos also went from -10 to 10 in the domain and the range. And I see that I got this really steep graph right here. And so when I look at my options, the only options that look like it could work, well, heck, these 3 options all look really steep going up. So I have to look at the particulars. Like in this case right here, I see that it's crossed past the y-axis into the positive side. Whereas if I go up here and look at this one doesn't look like it's really going to cross that y-axis. I know the printing kind of looks like it, but really what mathematicians are going to see is it's going to look like this, right? And so what we need to do is we need to look back at the graph, and we can see, ooh, it looks like it does indeed cross over, and we can kind of see that it crosses over, I don't know, right around 6 or so, right around here. So let's go over here and we're going to look. You know, I'm going to have to backtrack, and I'm going to have to say, I think the answer is A. Because if I zoom in, it kind of looks like it's going to cross right here at 6. 2, 4, 6, 8, 10. I see the scale is going by 2s. So I'm gonna have to go with the answer looking like it's A. I don't think that was a printing issue like I earlier said. I think the answer is A on that one. And the last slide for this video. So again, I had to get creative on how to type this into Desmos. And so when I did that, I'm going to go over here to Desmos. I had to use the time sign to make it work. And as I did that, I ended up getting this kind of a graph. I can see that it's crossing beyond into the negative side on the x-axis. Like as I go down here into the negatives, I can see that we go past the y-axis. So I can see that. And so when I go over here and I look, and I'm going to zoom in, it really looks like I'm going to have to go with B as the matching graph on this function. And that wraps up this video.